Hello everyone, in today's video we're going to cover section 10.3, arcs of a circle. After studying this section, you'll be able to identify the different types of arcs, determine the measure of an arc, recognize congruent arcs, and apply the relationship between congruent arcs, chords, and central angles. Next, looking at types of arcs. So an arc consists of 2 points in a circle and all the points on the circle that's needed to connect the points by a single path. So up above we have 3 different types of arcs. The first type is a minor arc. Minor arcs are points on or between the sides of the central angle, so essentially less than 180 degrees. Then we have major arcs. So major arcs are points that are on or outside the central angle, so greater than 180 degrees. And then we have a semicircle. A semicircle is an arc whose endpoints are on the endpoints of a diameter or 180 degrees. So minor arcs are less than 180, major arcs are greater than 180, and semicircles are 180. Now, the center of an arc is the center of the circle of which the arc is a part of. A central angle is an angle whose vertex is at the center of an angle. So we have circle O to the right. OA and OB are the radii that determine the central angle, angle AOB. Now, when we label arcs, we label using this symbol. When we label minor arcs, we label them with 2 letters. So in my diagram to the right, if I want to label arc AB, this one in red, I'd label it with just 2 letters, arc AB. Now, my major arcs, I label with 3 letters. This tells me and helps me avoid confusion about which arc I'm talking about. So if I'm talking about arc AXB, I start from A, go towards X, and finish at B, and then I would have my major arc AXB labeled AXB with my arc symbol. Next, looking at the measure of an arc, the measure of a minor arc or a semicircle is the same as the measure of the central angle that intercepts the arc. Remember, if I intercept the arc, the angle has points that are the endpoints of the arc. Now, the measure of a major arc is 360 minus the measure of the minor arc with the same endpoints. So looking at my figures above, I can see that I have minor arcs the same measures as the central angles. If I wanted to calculate the major arcs, I would take 360 and subtract the measure of the minor arcs. Now, if I want to calculate the measure of the major arcs in my figures above, looking at my first figure, I'd say 360 minus 120 would give me a major arc of 240 degrees. My second figure, 360 minus 90, would give me a major arc of 270 degrees. My third figure, I have a semicircle, so I would take 360 and subtract 180, which would give me 180, so I'd have another semicircle. And my last figure, 360 minus 30, would give me a major arc of 330 degrees. Now, looking at these 2 examples, we want to find the measure of each major arc that's listed. In A, we're given that arc AB is 20 degrees, and I want to find arc ACB. ACB, I can see, has the same endpoints as arc AB, so that would make up the whole circle. So 360 minus 20 would give me arc ACB of 340 degrees. Looking at B, we're given central angle XQY is 110 degrees, and I want to find arc XDY. Now I know that arcs have the same measure as their central angles. So arc XY would have a measure of 110 degrees. So 360 minus 110 would give me an arc measure of 250 degrees. So XDY is 250 degrees. Next, looking at congruent arcs, 2 arcs that have the same measure are not necessarily congruent arcs. Remember, measure is different from length. So looking at my figure to the right, I have concentric circles with arcs CD and AB that would have the same measure of 65. But because these are different circles, they would have different radii, giving the lengths of the arcs different measures. Arc AB would be larger than arc CD because the radii is bigger in that circle. So the definition of congruent arcs is 2 arcs are congruent whenever they have the same measure and are parts of the same circle or congruent circles. In my 2 figures, I can see that I have congruent arcs. So in my figure to the left, we have circle O with arcs AB and CD both having a measure of 60 degrees. Because this is one circle, each arc would have the same length. Now, looking at my figure to the right, we have circle P and circle Q. If circle P is congruent to circle Q, then arc EF would be congruent to arc GH because they would have the same length as well as the same measure. And lastly, looking at relating congruent arcs, chords, and central angles. In my diagram, points A and B determine one central angle, one chord, and two arcs, one major and one minor. If I look at the same circle or of congruent circles, I would have the six following theorems based on the central angle, the chords, and the arcs. Theorem 79 and 80, if two central angles of a circle or of congruent circles are congruent, then their intercepted arcs are congruent. So if I have congruent central angles, then I would have congruent arcs. And the converse, if two arcs of a circle or of congruent circles are congruent, then the corresponding central angles are congruent. Theorem 81 and 82, if two central angles of a circle or of congruent circles are congruent, then their corresponding chords are congruent. So if I have two corresponding central angles congruent, then I would have chords congruent. And the converse, if two chords of a circle or of congruent circles are congruent, then their corresponding central angles are congruent. And lastly, theorem 83 and 84, if two arcs of a circle or of congruent circles are congruent, then the corresponding chords are congruent. And the converse, if two chords of a circle or of congruent circles are congruent, then the corresponding arcs are congruent. Now we can summarize this to make it nicer. If we have the same circle or congruent circles, then no matter what, if I have congruent chords, I would have congruent arcs and I would have congruent central angles. And this works if and then. So if I'm given central angles congruent, then I would have congruent arcs and I would have congruent chords. Or if I have congruent arcs, then I have congruent central angles, I have congruent chords. Now looking at our sample problems, first problem, problem 2, if measure of arc AB is 102 in circle O, find the measure of angle A and the measure of angle B in triangle AOB. So the first thing we'll want to do here is draw circle O. Now I will draw in arc AB, and arc AB has a measure of 102. Now if arc AB has a measure of angle 102, that means the central angle also has a measure of angle 102. Now I can see if this is central angle of angle O, that AO and AB are radii, making them congruent, making this an isosceles triangle. So angle A and angle B will have congruent measures. Now if one measure of the triangle is 102, I could say 180 minus 102 is equal to 78. So A and B add to 78. I know they're both congruent, so I could divide this by 2 to give me an angle measure of 39 degrees. So angle A and angle B are both 39 degrees. Problem 3, what fractional part of a circle is an arc of 36 degrees and of 200 degrees? Now, I know the fractional part of a circle would be divided by 360. So 36 over 360 would give me that fractional part, which is 1/10. So if I'm 36 degrees, I'm 1/10 of the circle. Now, if I'm 200 degrees, 200 over 360, 200 divided by 360, I could take away a 0, so 20 divided by 36. I could divide this by 4, which would give me 5/9. So if I'm 200 degrees, I'm 5/9 of the circle. And lastly, part B, find the measure of an arc that is 7/12 of its circle. I know a whole circle is 360 degrees, so 7/12 of 360 would give me 210 degrees. So if I'm 7/12 of its circle, I'm 210 degrees. In today's lesson, we learned arcs consist of 2 points of a circle and all the points in between. A minor arc is less than 180, a major arc is greater than 180, and a semicircle is 180. A central angle has a vertex at the center of the circle, and if you have congruent arcs in the same or congruent circles, then you have congruent chords and congruent central angles. That's a wrap on today's video. We'll see you in the next one.